Good day again. So the last of the advanced statistical graphs we want to look at is the histogram. And the way we get the histogram is frequency again going on the y-axis, but the upper and lower boundaries, both of them going to form something that looking like a bar graph, looking like a bar on the x-axis, as you'll see. So that's where the boundary is going to come into play. And like I said, it's going to look like a bar graph, but it will be joined because it's for continuous data. This is the least popular out of the three graphs that we're going to look at for the advanced graphs at least. So let me see what it will look like with a recent question, which was June 2010. So we have June 2010 right here. And for June 2010, we have a class of 24 students throwing a cricket ball. And the distance thrown was recorded. So again, this is the raw data here. That's what we call the raw data. And they fill out some of the table for us already. And we need to fill out the rest for 3 marks. Each line going to be a mark then. So they didn't do the intervals, but again, the interval is just a pattern. 20 to 29, 30 to 39. How much you jumping by? 30 minus 20, jumping in 10. So that means 20, 30 here going to be 40, 50, 60. Or you could do it going across if you like. 29, 39, 49, 59, 69. And once I fill in the interval, now I could see how much in that interval. So 20 to 29, the numbers that fall into between there. 122, 123, 129, that's how they get 3. And so on. 40 to 49, a circle for 40 to 49. 1, 2, 3, 4, 5, 6, 7, 8. So I'll get 1 mark for that row there. 50 to 59, want to check it, and you can check it yourself. 6. 60 to 69, 2. And if you want to just double check, all these people here, when I add them up, had to totally 24 students. Let me just double check that, adding up quick. 8 at 2, 10, at 6, 16, at 5, 21, at 3, 24. So it is totaling the 24. We account for everybody. Table finish, we get 3 marks. Next part now is state the lower boundary for the class interval. Now this does use boundaries, and this is kind of like a hint to let you know, hey, this have to use the boundaries. So again, the boundary is 0.5 less, 0.5 more on either limit or either end. So this is going to be 0.5 less, 19.5, 0.5 more, 29.5. All they asked was for the lower boundary though, so my answer would have been 19.5, but that coming into play because this uses the boundaries. So I really need 19.5 and 29.5, and wherever he stop off, I minus off it 29.5 to 39.5. Wherever he stop off, he start back. So this one was really using the boundaries, and like I said, sometimes even the cumulative frequency curve would use the upper boundaries, so it will be these numbers with the 0.5s added to them. But these are the values that are going to go on the graph, as you're going to see just now. But again, just like before we actually come to the graph, I want to do the probability piece and the little extra piece they have here. So this part, determine the number of students who threw the ball a distance of 50 meters or more. So 50 meters or more. This is not the probability part yet. You just want to know how much people throw the ball. 50 meters or more. So again, I could use the raw data, or I could use the table that already grouped it up for me. 50 or more means I include in 50 this time and more than 50. So this is 50 or more. 50 and up. And these are the people that would have scored 50 or more. So 6 had 2, 8 people scored, or 8 students scored, threw the ball a distance of 50 or more. And again, if I wanted, I could just check it on the table quickly. 50 or more, I'm looking for anything 50 and higher. 1, 2, 3, 4, 5, 6, 7, 8. Same 8 we get, but again, sometimes you do have the raw data and have to use the table, so it's good to know how to get it from the table as well. Now the last part is the probability that somebody chosen from the class threw the ball a distance 50 or more. So I have my fraction set up because probability would be a fraction. How much children from the class are choosing from again? There it is, 24 children in the class. And how much children threw the ball 50 or more? Well, they make me find that in this piece. So the answer is 8 over 24. And if I want, I could break it down to a third, but either of those would be fine. The last part now is the graph. I want to draw the graph. You realize they give me the scale again. And just like before, notice that it had nothing from 0 to 20. But because of the 19.5, we wouldn't have anything from 0 to 15. So let me have it set up like that. And let's see what it's going to look like when I do my scale. 1 centimeter jumping 5s for the x-axis, and 1 centimeter representing 1 on the y-axis. So when I start sketching up my scale, I already do up a scale here already. Again, my y-axis is frequency, my x-axis is the distance, and from the distance I'm going to use the upper and lower boundaries for each at the intervals that they would have given me. So again, every 5 tiny blocks are jumping by 1 on the y-axis, and every 5 tiny blocks are jumping by 5, because again that's what the scale would have say, 1 to 5 on the x-axis and 1 to 1 on the y-axis. So the scale is taking a while to get accustomed to. So now let me see what it's going to look like when I want to plot my points, because I already have my upper and lower boundary. These are the important piece here. This is the lower and this is the upper boundary here, because we're using the boundaries, the 0.5s. So I need to mark off 19.5 and 29.5, which I already did here. So 19.5 and 29.5, and both of them go into a height of 3. So again, using a ruler, I'm holding my phone with the next hand so I can do the ruler. And the weird thing about this question though, you had to go in between the line, which was a poor choice of scale by CXC, but that happens sometimes. So we actually had to go in between the line, because each one of these was 1. 16, 17, 18, 19, 20, 26, 27, 28, 29, 30. So to get 19.5, I actually had to go in between the line. And then we continue. The next one would have been 29.5 to 39.5, going to a height of 5. So 29.5 to 39.5, and I already have it to a height of 5. Again, it will look better with a ruler. All the rest, when you fill it in now, 39.5 to 49.5 is 8. I carry it up to 8. I in between the lines, as you can see, because I did use a ruler for those. And then I finish off my graph. And as you can see, that's what the graph going to look like. Very similar to a bar graph, but it's for continuous data. And to note, this very similar to a frequency polygon as well. So if I was to actually find the midpoints at each of these, meaning I in the exact middle of this graph, and I was to connect the consecutive points, it'll be a histogram. Sorry, it'll be a frequency polygon. So that's how the frequency polygon relates to the histogram as well. If I was to use the middle points, which is the midpoint, we would get the frequency polygon instead. So this is what an example of the histogram looks like. Again, is the least popular out of the 3 graphs we would have looked at as well.